In this video, we are going to look at an application example involving integration by parts. So here's the example. We have this word problem. Lavender works part-time as a tutor during her 4 years of college. She initially charges $25 per hour, but increases her rate by 6%, continuously compounded annually. Okay, so that is a concept from Math 30 from the previous calculus course. At first, she works 100 hours per year, but as she gets more experience, she increases her work hours linearly up to 220 hours per year over that 4-year period. So by the end of these 4 years, she's working at a clip of 220 hours per year. Question is, how much does she earn tutoring during college? Round to 3 decimal places. Okay, so that is a lot of information there. But let's see if we can start to break this down. So what is this question asking for? It's asking for how much does she earn tutoring during college, which is over those 4 years. So it's asking for the net money that she earned. Okay, and when a question is talking about the net of something, the net change in this case of money, that we can evaluate using an integral of the rate of change of whatever that quantity is. In this case, it's the rate of change of her earnings. So the rate at which she's earning money during these 4 years is changing because of two things. She's charging more over time, and she's working more hours over time. Okay, and then I have to put a dt here. And what's my time period? So in this question, we're going to measure t in years. So this is over 4 years of college. So we're going to say from 0 to 4. So maybe I should say, be more specific about what t is. T is years from when she starts college. So that's what the interval is going from 0 to 4. Okay, so we are going to have to think about how we would compute this rate of change of her earnings. So the rate of change of her earnings. Let's focus on this. The rate of change of her earnings depends on two things. Sort of conceptually, if we want to think about how much she earns, we'll have to multiply two things together. We'll have to multiply the rate that she's charging, and then combine that with the hours that she's working. So on one hand, we will need to know her tutoring price, which is changing over time, and we will also have to multiply that by her hours working rate of change. So I'm about to go to the next page to really break down now how to get both of these things, the tutoring price and the hours working rate of change. But the next page doesn't have the word problem written out anymore. So if you don't have it written down in your notes, I'd encourage you to take a screenshot or something of this so that you can refer back to it as we continue to talk about the problem. Alrighty, so I've copied down that formula that we had here. So let's break down both of these things in parentheses. Her tutoring price, the question told us, was being compounded continuously, which is something that we talk about in Math 30 in the previous calculus class. But there's a formula to determine what that is, and it's P times e to the RT. Or sometimes people just refer to this as PERT. So P times e to the RT, this is talked about in sections 2.2 and 2.3 of our textbook. You can also refer back to my videos from when I taught Math 30. I have videos on this section to give you a refresher on this topic. Okay, so I'm going to start to plug into this formula. So P represents the initial amount. In this case, it's the initial price that she's charging, which is 25. And then we have E, and then R is the interest rate when you convert it to a decimal. So R, in this case, is the rate at which her price is increasing, which was 6%. 6%, if I write that as a decimal, it is 0.06. And I have to multiply that by T, because that T is there in the formula. And what are the units of this? This is in dollars per hour. She charges this many dollars per hour. And this is something that's changing over time. The more time that elapses, the higher this value gets. And on a conceptual level, I think that makes sense because in the real world, as tutors get more experience, they typically charge higher rates over time. All right, let's find hours working. We need to express that as a function as well because that's changing over time. The problem is that this is changing linearly. So we can take the information that it gives us and see if we can write down what it is in terms of 2 points. So I can write down the equation of a line. So one piece of information that it tells us is initially, when at the start of college, that would be t equals 0, the number of hours, I'm going to call that h, that she's working is 100 hours per year. That's the rate at which she's working. Okay, so h represents her hours working. Okay, and then by the end of her time in college, so by the end of the 4 years, the rate at which she's working is, she's increased that to 220 hours per year. All right, so we have these 2 points. So let's write down an equation of the line connecting them. So we're going to need to know the slope. So the slope would be, so we'll subtract the y values, 220 minus 100, over subtract the x values in the same order. So 4 minus 0. It doesn't matter what order you do the top, as long as you stay consistent on the bottom. Okay, and this simplifies to 120 over 4, which is 30. So about 90% of the time in calculus, it is easier to write down the equation of a line using point slope form rather than using y equals mx plus b. So point slope form, as a reminder, is y minus y1 equals m times x minus x1, where x1 comma y1 is a point on the line. Okay, so if we start to write that out for our problem right here, we would get something of the form y minus y1 equals the slope times something minus something, x minus x1. But in our problem, we don't have y as a variable. The y coordinates of variable is h. And then similarly, within the parentheses, we don't have x as a variable. Instead, we have t. So let's put a t instead of an x. And then I can take either one of these points, but it seems like the simpler point to use would be 0, 100, just because they're simpler numbers. So I would do h minus the y coordinate of the point that I'm using. So if I'm using 0, 100, the y coordinate, in this case it's the h coordinate, would be 100, equals the slope, m, 30, times, in this case it's t minus the t coordinate of that point. And the t coordinate is 0. And if we rearrange this, we get that h equals 30t, and then add the 100. So h equals 30t plus 100. And the units of this are, these are the hours that she'd be putting in per year at whatever time we're talking about. All right, so I'm going to zoom it out a little bit. We are ready now to plug this in to the formula for the rate of change of Lavender's earnings. Because what we need to do is multiply these two expressions that we just got. So her tutoring price was 25 e to the 0.06t in dollars per hour. And then that gets multiplied by this value for h, which was 30t plus 100. And what were the units? Hours per year And one of the ways that we know this is good is if we look at the units. The hours would cancel, and after the hours cancel, the units end up being dollars per year. And it makes sense that the rate of change of her earnings would be measured in dollars per year. So that is good. So the units look good here. Okay, so now we are ready to plug this in to our integral. All right, so let's scroll it down and let's plug in to an integral. Alrighty, so thus, whoops, there we go, thus, her net earnings, and I'm going to highlight this, this is ultimately what we're after, her net earnings. Remember, we said that they are an integral from 0 to 4 of the rate of change of her earnings. But now we know what that rate of change is. It's going to be 25 times, and I'm going to rearrange the terms a little bit. I'm going to put the polynomial term first, 30t plus 100, and then times that e term, e to the 0.06t, got to write that dt. So I'm going to do one thing to simplify this, and then pause the video and let you all try the question. Because part of what made this question difficult, or I would say more difficult than the examples that we've looked at, is it was harder to come up with this function. We had to do some algebra and rely on some previous knowledge, or maybe review some stuff about p times e to the rt to figure out, what each of these pieces were. But now we still have to evaluate this integral. So there are a bunch of steps here that we're all combining together. Okay, so I'm going to do a simplification and then let you all try this. 25 is a constant, so I can pull that to the front. But I noticed that within the parentheses, with a 30 and the 100, we can factor out a 10. We can factor out a 10, and that's nice. So let's pull that 10 to the front of the integral. And that'll leave us with the integral from 0 to 4. 3t plus 10 times e to the 0.06t dt. All right, so this is where I'm going to leave it for you to try. Take about 3 to 4 minutes and try to evaluate this integral. I'm not going to tell you what technique to use. I want you to see if you can figure out what technique to use and see if you can follow that through. 4, 3, 2, 1, pause the video. Pause it for 3 to 4 minutes to really try this integral and see if in this time you can figure out, well, what is the method that helps? Is this something we can just do the antiderivative of? Is this by parts? Is this u sub? And then see if you can get that started. It's probably not going to be enough time to finish this question. All right, so hopefully you've done that. Hopefully you've paused it for about 3 to 4 minutes to really try this. So we've seen an example like this before, our very first example that we did in this section, 7.1. And the method is we use integration by parts. Integration by parts. So we need to choose a u and choose a dv. And I'm going to let u be the linear thing, 3t plus 10, because its derivative will be quite simple. And let dv be the exponential thing, e to the 0.06t dt. And if we do that, du, derivative of this is 3, and I have to write a dt next to it. And for v, the antiderivative of e to the 0.06t would be e to the 0.06t, but I need to have a 1 over 0.06 in the front. And if you're unsure about why this is what v is, I would encourage you to take the derivative of this and make sure you get e to the 0.06t. That's what v is supposed to be. It's supposed to be something that you take the derivative of to get e to the 0.06t here. Alrighty, so we have the choice of everything, u and dv, and then figured out du and v based off of that. So now if we plug in using our formula, we'll get u times v, which is, oh, and I can't forget the 25 times 10 in front of this. So let me give myself some more room, actually. The 250 in front, and then let's plug in. So u times v is going to give me 3t plus 10 times e to the 0.06t all over that 0.06. And I'll need to plug in the 0 and the 4, minus the integral from 0 to 4. of v du. So multiplying those, I'll get 3 over 0.06 times e to the 0.06 t dt. And close that bracket, because this 250 was in front of the whole integral. So 250 should be multiplying all of this. All right, so now let's do this antiderivative, and then we'll start to think about plugging in. So we'll have 250 in front of this whole thing. So the first part stays the same, 3t plus 10 e to the 0.06t over 0.06, 0 to 4. I'm holding off on plugging in 4 and 0 into this, because maybe after I do the antiderivative, I'll be able to factor something out, like I did in the last video, to make my arithmetic easier. Okay, and then with this integral, the 3 over 0.06, I can keep that, I can factor that out, and then we know how to do the antiderivative of e to the 0.06t. In fact, we did it up here. It was right over here. So that is 1 over 0.06 times e to the 0.06t. Okay, vertical line to indicate I need to plug in 0 and 4. Close that bracket. Alrighty, so we are almost there. We have done the hardest parts. We've done the setup. We've done the antiderivative. It's just some plugging in, maybe some factoring. So we got 250 factored out. And then I noticed that e to the 0.06 is common. So, whoops. Went to highlight, not do that. Okay, let's back it up. E to the 0.06t is common. And this 0.06 on the denominator is common. So let's factor that out. Okay, so in fact, let me scooch that down there so I can write out that we are going to factor, whoops, hold on, I want to write with a smaller pen. So we want to factor out that e to the 0.06t over 0.06, because it was common to both of these terms. So when we do that, the e to the 0.06t over 0.06t over 0.06 gets factored out. And then in parentheses, I have to put what I'm left with. So from the first term, I'll be left with 3t plus 10. From the next term, I'll be left with minus 3 over 0.06. 3 over 0.06. And now I need to plug in the 0 and the 4. So notice that factoring that term out made this expression look simpler. So it's going to make my arithmetic easier. So let's plug in, and we'll get 250 still in front. And now times, when I plug in 4 into this, we'll get e to the 0.06 times 4 is 0.24, and then divided by 0.06. And in the parentheses, 3 times 4 is 12, plus 10 would be 22. So I'll get 22 minus 3 over 0.06. Okay, and now I have to subtract what I get when I plug 0 in. And when I plug 0 in, I'll get e to the 0, which is 1, over 0.06. And then in the parentheses, I'll get 3 times 0, which is 0, plus 10. That's 10. And then minus that 3 over 0.06. Okay. And if I needed to do this without a calculator, this is about as far as I would ask you to go. Do the antiderivative, simplify it as much as you can without a calculator, and then plug in. So this would be an okay stopping point. But this question said to round your final answer to 3 decimal places. So if we do that, we end up getting 18354. This is where I plug into a calculator. 354.266. And the units of this are supposed to be, it's supposed to represent how much money she makes from tutoring. This would be in dollars. This is how much money she makes over her 4 years. Alrighty, so in terms of our goals, we have finished our 3rd goal, which is doing an application example. This was definitely a step up in difficulty, but there are a lot of really good concepts in here that we practiced integrating together and combining. All right, in the next video, we will review our methods for computing antiderivatives and look at one final example.